Let's look now at problem 7 from the review sheet. Problem 7 states, the order is 2.5 milligrams per kilogram of a drug for a patient weighing 68 kilograms. So here we have a situation where a drug is administered at different strengths based upon the size of the person, or I should say at different amounts. The strength remains the same, 2.5 milligrams per kilogram, but the amount of pure drug that the patient will receive will depend upon the patient's weight. So it told us that the rate of administration of the drug is 2.5 milligrams for every 1 kilogram of a patient's weight. This basically gives us a conversion fraction we can use. And it said that the patient weighed 68 kilograms. Make sure I've got those figures down right here. Then the problem went on to say each capsule, so we're going to be giving the drug to the patient in capsules, each capsule contains 50 milligrams. Okay? So 1 capsule of the drug equals 50 milligrams. How many capsules would you administer to the patient? So our end question is, how many capsules? How many capsules are we going to give to a patient who weighs 68 kilograms when the drug is to be administered at 2.5 milligrams per kilogram, and we're giving it to them in capsules that each contain 50 milligrams of the drug? So in these problems, our approach has been to first calculate how much drug this patient needs to receive. And that's done by starting with the patient's weight and multiplying it times the rate of application. And of course, when we do that, we see that those kilograms are going to cancel. And if we did the arithmetic right here, we would know the total amount of drug that this 68 kilogram patient should receive. This is the total amount of drug. And now we need to put it into the correct form based upon information that we have about the drug and the form in which it's given. And that's the equivalence right here. 1 capsule contains 50 milligrams of the drug. And that's what I want to end up with is capsules. So I want milligrams to cancel with the milligrams that are here. I want to end up with capsules. To end up with a unit of measure, it has to be in the numerator of one of our conversion fractions. And 1 goes with capsule when 50 goes with milligrams. So milligrams now cancel, and the result that we have is capsules, the unit of measure we wanted. Now if we do this arithmetic, and the nice thing about it, we can do this with our calculator, which will help us some. So we would take 68 times 2.5, divide that result by 50, and when we do that, we get 3.4. So that says 3.4 capsules. Well, now this is a question you really need to talk to your medical instructors about. What would be done in that instance? If these happen to be, well, these are capsules. If we were giving them in tablets, and in particular in tablets that were scored tablets, meaning they can be divided, then perhaps we would give them 3.5 of those scored tablets. But if you're giving them in capsules, it's very difficult to give a partial capsule. So the question is, do we then simply give them 3 capsules as being as close as we can get to what the prescribed amount would have been? And again, those are not questions for a math instructor. Those are questions for a medical instructor, which you can discuss with them in the classes that you have.